Okay, this is part 2 of the Chapter 2 review. We have 2 rational functions. You have to find all of this stuff, starting with domain. Remember domain. And actually what I will do, I'm going to go ahead and start the factor process, x minus 2 over the bottom factor is x plus 2, x minus 2. But I will find the domain before you cancel. So remember that when you're finding domain, do it before canceling. Which is that's crap writing, but hey, whatever. So my domain, remember your bottom cannot equal 0. So for my domain, x plus 2, x minus 2 equals 0, and you get x cannot be negative 2 or 2. In interval notation, that would be everything before negative 2, everything between negative 2 and 2, and everything after 2. So there's my domain. I've done part A. Factor and cancel. I've already factored. Now I just need to cancel. I can cancel the x minus 2's. And remember, when you cancel something, I'm going to go ahead and make a note that I have a hole where I canceled. And I canceled x minus 2, so I have a hole at x equals positive 2. The hole is whatever makes that factor 0. And after I cancel, I'm left with everything is gone on top, so I have a 1 on top and an x plus 2 on bottom. Okay, part C, find any holes. I actually just did that. But whatever factor you canceled, I canceled x minus 2, set that equal to 0, and you get a hole at x equals 2. That's the x coordinate. Now, I do ask you to sketch the graph, so I'm going to go ahead and find the y coordinate also for the hole. And to get the y coordinate, you plug x equals 2 into the reduced version. So that'll be 1 over 2 plus 2, or 1/4. So more specifically, I know my hole is at the point 2, 1/4. And that's probably a better location for the hole, although if all you said was a hole at x equals 2, that's okay for part C. But when it comes time to graphing, you need to have the y-coordinate also. Find vertical asymptotes. Vertical asymptotes are values that make your denominator 0 after canceling. So I have an x plus 2 in the denominator. You set that equal to 0, and I have a vertical asymptote at negative 2. X equals negative 2. So there's my vertical asymptote. Skipping on to E, horizontal asymptotes. Those are the ones where you look at the degree on top and bottom, and you can look either at the reduced or the original. It doesn't matter. I kind of like to look at the original. My top degree is 1, my bottom degree is 2. If the bottom degree is bigger than the top, your horizontal asymptote is y equals 0. So I've done E. The slant and oblique asymptotes. You only have a slant asymptote if the top degree is 1 more than the bottom degree, so there is none. Find the x and y intercepts. Okay, so the x-intercepts, that is when you set your numerator equal to 0 for the reduced fraction. So my numerator is 1. If you set that equal to 0, there's no solution. The top will never equal 0. The top is 1. That means there is no x-intercept. The y-intercept, hey, I just changed to blue. Don't know why I did that. Okay, the y-intercept, you plug in 0 for your x, and you can plug it into the original or reduced. I like reduced, so I'm going to plug in 0 for x, 1 over 0 plus 2, and you get a y-intercept of 1/2. Okay, and then finally, the last thing I ask you to do is sketch the graph. And so we'll sketch this graph. All right, shrunk stuff up to give me a little bit of room to graph. And to graph this, I'm going to start by graphing all of our information that we already found. You don't really graph the domain. Okay, there is a hole at the point 2, 1/4. So I'll go over to 2. So let's see, there's 1, here's 2. I'll call this y equals 1, y equals 2. And I have a hole at 2, 1/4. We're just going to put a hole right around there. So I'll go ahead and graph the hole. Let's see, I have a vertical asymptote at negative 2, so let's go negative 1, negative 2. And I'll graph a vertical asymptote there. So there's a vertical asymptote. A horizontal asymptote on the y-axis, or at y equals 0, which is the x-axis. So there's a horizontal asymptote. I do not have any x-intercepts. I do have a y-intercept at 1/2, so let's graph a y-intercept at 1/2, which is going to be about right here. and I don't hit my x-axis ever, I have an idea that this piece right here is going to come down like this, following the asymptotes, kind of like in the first quadrant there. But I'm not so sure what's happening on the left side. So what I'm going to do, just to be sure what's happening over here, I'm going to plug in, this is y equals x equals negative 3. Hey, my phone's ringing. And I'm going to plug that in real quick, and I'll plug into the reduced form. If x equals negative 3, I have 1 over negative 3 plus 2, which is 1 over negative 1, which is negative 1. And that would give me the y value. So negative 3, my y coordinate is negative 1. So I'll plot a point there. And that's enough to let me know that my graph is following down like this on that side. On the right side, I already have a point up here, so that's enough to tell me that my graph is going to come down like this. You have the whole, going to kind of do that and follow the asymptote. And there's our graph for number 3. All right, next problem. Same thing, find the domain, all this mess. Let's see. Again, I like to go ahead and factor a little bit before I find the domain. On the top, you can take out an x, which leaves you x squared minus 5x plus 6. On bottom, that factors to, you know what, you know how to factor. I'm going to pause it while I factor. There we go. All right, so we factor. Then I'm going to find the domain, which part A domain is your bottom cannot be 0, so x plus 3. X minus 3 cannot be 0, which means x cannot be negative 3 or 3, which is in interval notation, everything before negative 3, everything between negative 3 and 3, and everything after 3. So that'd be 3 to infinity. So there's my domain. Okay, then let's see, I notice factor and cancel. I can cancel an x minus 3, which I'm going to go ahead and answer C since I saw some canceling. So C, I canceled an x minus 3, which means I have a hole at x equals 3. Then I'll go ahead and write the rest of this x minus 2 over x plus 3. And to find the y coordinate for my hole, I'll plug 3 into my reduced form. So that's 3 times 3 minus 2 over 3 plus 3, and that reduces to 1/2. So my hole is at the ordered pair 3 1/2. So there's my hole. Moving on, any vertical asymptotes, that's what makes the bottom 0 after canceling. So my vertical asymptote is going to be whatever makes x plus 3 0, because that's my final denominator. That gives me a vertical asymptote at negative 3. Horizontal asymptotes, so see, I've already done A, B, C, D. Horizontal asymptotes, top degree is bigger than the bottom degree. That means there are no horizontal asymptotes. But what's going to make this one a little bit trickier is I do have a slant asymptote because the top is 1 bigger than the bottom. And this one we talked about in class, but I don't know if we ever had one where this actually happened in class. To find the slant asymptote, we divide the bottom into the top, which isn't going to be very tough. Now to do my slant asymptote, I will distribute through the top. I have x squared minus 2x over x plus 3. And then I'm going to do synthetic division with that. It's x plus 3, so negative 3 into, excuse me, x squared minus 2x, which is 1x squared minus 2x. I have no constant, so there's plus a 0. Bring down the 1. 1 times negative 3. Negative 2 minus 3 is negative 5. Negative 3 times negative 5 is 15. Okay, and what you do is you disregard the remainder for the slant asymptote. And what I'm left with is y equals 1x minus 5. And that is the slant asymptote. If you think about that graph, the line 1x minus 5, that's a y-intercept of negative 5 and a slope of 1. So there is my slant asymptote. And that's kind of my fault. I don't think we've done one of those before. So there's your slant asymptote. X and y-intercepts are pretty easy. X-intercepts, you set your numerator equal to 0, which my final numerator was x minus 2. So we have x-intercepts at 0 and 2. We actually have 2 x-intercepts. And then my y-intercept, I'm going to write my y-intercept over here to give me a little bit more room. Y-intercept, you plug in 0 for the x. My y-intercept is 0 times 0 minus 2 over 0 plus 3, which reduces to just y equals 0. And then we now need to graph everything. All right, so to graph this, we start by graphing, I have a hole at 3 1/2, so let's see, 1, 2, 3, we'll call that 1, and 1/2 is going to be about right there, so I have a hole at 3 1/2, I have that graph. D was a vertical asymptote at -3, so I'll go -1, -2, -3, and there's my vertical asymptote, so let me graph that in. Close enough. Let's see, there was no horizontal asymptote. I do have a slant asymptote at x minus 5, and here's what we're going to have to do for the slant asymptote. I just graph the line y equals x minus 5, so I need to go down to a y-intercept of -5. Ooh, this one's going to be, doo-doo, I didn't give myself room to graph this. Snot buckets. I should have anticipated this. My slant asymptote has a y-intercept of -5 and a slope of 1. Now this is an asymptote. This is not like a y-intercept for my actual graph. So I'm going to graph the line -x plus 5, which has or x minus 5, so it has a y-intercept of -5 and a slope of +1, which is going to go in both directions. And where I messed up is I don't have room to sketch this on the graph I've created. So what I will have to do is go to the next page and create more room. All right, here we go. I'm trying to graph that slant asymptote again. The slant asymptote had a y-intercept of -5, so 1, 2, 3, 4, 5, and a slope of +1. So my slant asymptote is going to look like this. There, that's better. And then we do need to go through and graph, let's see, there. Then we do need to go through and graph all the intercepts. I had an x-intercept of 0 and 2, and a y-intercept of 0, so let's go graph those. An x-intercept of 0 and 2, so x-intercept of 0, an x-intercept of 2, and a y-intercept of 0. And these 2 points are enough to let me know that I'm going to have to come down this vertical asymptote, and then we're going to quickly turn around and follow this slant asymptote. Don't forget we do have that hole at 3 1/2. I'm going to come down, hit that point. AO's about to start, come back up. I have a hole, and then I'll follow my graph back out this way. And then what I'm going to do is I'm going to plug in -4 just to see where my graph is. I plug in x equals -4. I get a y coordinate of, and I'm going to plug it in right here, -4 times -4 minus 2 all over -4 plus 3. That's what -4 times -6 over -1, which gives me a final value of -24. So when I plug -4 in, and I plugged it in right here, I got -24, which tells me that my graph at -4 needs to be way the heck down at -24, which I'm not going to be able to really graph that because it's way off the graph, but I do know that my graph is going to be in this little piece. So that ended up being a little bit more difficult than I anticipated because of the way the slant asymptote lined up. But there is the other two, the graphing problems.